The term domestic wastewater refers to water that has been used within a community, and that includes any substances that were added to the water while it was being utilized. It must be treated prior to disposal or use. The growth of industries, agriculture, urbanization, and population pose a threat to our water resource. The Environmental Quality Act controls the quality of effluent by suitable method. The objective of this project is to improve quality of wastewater, to preserve the quality of natural water resource, and to eliminate pollutants and toxicants. At the end of this project, it is to expect that the method of microbial fuel cell (MFC) in treating the domestic wastewater can be used to speed up the natural processes of purifying wastewater. It also can be used to eliminate pollutants and toxicants generated by municipals and industrial waste. Apart from that, the quality of natural water resource in Malaysia should be preserved by utilizing this fuel cell technology. Last but not least, the quality of our wastewater is expected to be improved and safe to use daily. As for the budget, up to 10% of a local government's annual operating budget can be attributed to energy consumption. 35% of typical municipal energy expenditures used by water and wastewater utilities. Last but not least, 25 to 40% of wastewater operational budget and 80% of drinking water processing and distribution costs is used for electricity. This project will begin by designing MFC before preparing the materials of construction. We will then identify the factors that decrease cell voltage, preparing instruments for measurement, MFC application, finalizing the MFC outlook, distinguishing methods of electrons transfer, and last but not least, calculations and procedures for reporting data.
Domestic wastewater treatment system requirement need the use of an alternative treatment method that are cost-effective and use less energy for efficient operation. Organic material found in domestic wastewater can be considered as a significant material that can be used to generate renewable energy. Thus, we choose microbial fuel cell technology, which converts organic material into electric current and is catalyzed by microorganisms. Figure 1 shows the MFC mechanism, which is made up of an anaerobic anode chamber and aerobic cathode chamber, separated by a proton exchange membrane. The anode is injected with a mixture of anaerobic sludge and a substrate such as glucose, whereas the cathode is injected with aerobic sludge. In the anode chamber, bacteria oxidize electron donor fuel to produce electron and protons. Transfer of electrons to the cathode through the external circuit, which powers the external device, and transfer of proton internally through the membrane. On the cathode, electrons and protons are utilized, converting oxygen to water and creating electricity.
The advantages of microbial fuel cell are MAC is an alternative source of fuel. It is a bioelectrochemical device that converts chemical energy contained in organic substrates into electrical energy by activities of microbes. Plus, MFC helps reduce atmospheric carbon dioxide by using it to rebuild fuels. Apart from being an energy source, MFC also has the potential to provide sustainable power resources to isolated communities and desalinate water. The smallest MFC produces equal amounts of power produced by the larger MFC and also increases the power output level as the fuel cell volume decreases. Disadvantages of microbial fuel cells are the low growth rate of microbes because they are very sensitive to changes in the configuration, source of inoculums, and substrate initial pH value. If a toxic event occurs, microbial activity is inhibited and thus the power output of the MFC decreases. MFC produce low power output. So far, several MFC were simply connected in series or in parallel to overcome the low voltage or power issue. MFC have porous electrodes that allow reactant to diffuse through them to react with ions in the electrolyte. The membrane is high cost. Membranes in MFC can represent up to 60% of the MFC total cost. The electrodes are usually made of cost-effective materials, but the cathode often contains platinum to speed up the reaction that creates the electricity.
A project description for how fuel cell could solve the environmental pollutions. First is the microbial fuel cell, novel and sustainable approach to harvest electricity through biological route. Combines the conventional electrochemical cells with the biocatalytic actions of microbes to harvest the bioelectricity. And then it is significantly devoted to alleviate the environmental stress associated with the emissions of greenhouse gases into the environment, proportionate to the economic growth of the nation in order to lead the industrial and technical advance. And microbial fuels also emerging in green technology could be an intensive alternative to reduce the burden of increased energy crisis and meet the social needs. And then it is most conventional wastewater treatment technology is not as efficient to remove the substantial amount of pollutants from greywater. That's all. Thank you.
Fuel cells are effective and environmentally friendly technologies that electrochemically convert the chemical energies of fuels into electric energy, while microbial fuel cell (MFC) uses microorganisms to catalyze the conversion of organic material into electrical current. The use of MFC technology can be related to the principle on waste prevention, use of renewable feedstocks, and real-time pollution prevention. MFC is an eco-friendly application that uses any type of waste from wastewater, agriculture, food, and more. These kind of materials that microorganisms use as a substrates for the metabolic processes have a significant impact on the operational and effectiveness of MFC. When wastewater is used as a source of substrate, two benefits can be achieved, such as the cost of electricity that is generated can be reduced and the treatment of the wastewater can be advanced. MFC employ domestic wastewater for the renewable energy industry, which contributes substantially to bioenergy production. The advancement of MFC technology has made it possible for numerous microbial communities to use wastewater as in fuel cells. The higher percentage of moisture present in the waste would be beneficial in breaking through the barrier. Bacteria might have an easy time decomposing the solid biomass with a number of different types of wastewater resources. Thus, bioenergy production can be increased by different types of waste with numerous MFCs. MFC is regarded as one of the promising remedies to resolve the issue of energy shortage and environment pollution. It can create renewable energy directly through the anaerobic oxidation of organic substrates in wastewater. Besides that, it can be utilized to supply energy to measurement equipment that used to track the environmental changes through sensors positioned all around the area. It can be also considered a pollution sensor because the distributed organic matter sustains microbial activity. In overall, MFC technology may provide a reliable and long-term solution since it emits no harmful compounds. Thank you.